Okay, good afternoon everyone. My name is Shailesh Kr. I am Executive Director of Building Materials and Technology Promotion Council, and today we are going to run a very special podcast at MNIT Jaipur. Today, as you know, I along with Professor C.V.R.Murty, Professor S.D.Bharti, Professor Sanjeev Singh, Engineer Jaswant Arlekar have assembled here to witness one of the tests to promote use of steel in housing for vernacular typology bhutia at National Earthquake Testing Facility established at MNIT Jaipur. So first I would like to ask Professor Bharti that what is the intent of establishing this NETF acronym at MNIT Jaipur?
Namaskar. Namaskar. The National Earthquake Testing Facility at MNIT Jaipur has been established with the ultimate objective of ensuring earthquake safety of people of India specifically and earthquake safety in general. As we understand that earthquake safety, as earthquake excites the structure, what is causing is a displacement. So what is required is that we'll have to investigate the behavior of structural systems at various levels right up to the inelastic range, either through analysis and through full scale testing. So the safety in earthquake is primarily critically मुख्य तौर पे इस चीज पे डिपेंड करती है कि आप उसको पूरा डिस्प्लेस करके उसका डैमेज का पैटर्न और उसका डैमेज का नेचर समझें. So that is how we started National Earthquake Testing Facility at MNIT Jaipur. The primary aim is that we test the systems right up to the full capacity, force as well as deformation. That was the primary objective, and we are trying to promote newer technologies, newer systems which do not have established design methods, and we are testing at various levels, but most of the tests are full scale. We are testing connections, sub-assemblages and full scale systems. We have done testing of newer technologies, emerging technologies, faster technologies, sustainable technologies up to 3-story structures. This is one of the biggest test facility and one of the facility where we have done some of the big, path-breaking landmark tests in the country, and we wish to meet the aspirations of earthquake safety of people of India.
Okay, Professor Bharti, I know you have started this facility very recently. We would like to hear from you what are the facilities you have in this testing facility.
So as I just said that we have the test facilities capable of doing quasi-static reverse cycle testing of structural systems, which includes beam column connections, column base connections, and various other connections as well. I mean, on the higher side, the capacity is that we can test buildings and structural systems up to 10 meters of the height. So 10 meters of height meaning thereby it will be 3-story structure, which different kind of systems, the precast systems, pre-engineered systems, and also at the same time, other than the buildings, we can also test bridge piers of up to 2-meter diameter and the bridge girders also. So anything to the capacity of 10 meters in height, and we have actuators. We have about 5 actuators, and our actuators are one of the largest in terms of capacity in terms of international standards. We have actuators which can take load up to 100 ton or 1000 kN with displacement capacity of plus minus 500. And when you compare the size of actuators that we have here, meaning thereby one of the largest tests in the world comparatively, we can do one of the largest scale tests in India, and the facility is comparable to the global facilities of similar kind across the world. And of course, as I told you, we are one of the biggest in the country also in terms of size as well as activity level. And besides the reaction floor wall system, in that we are doing testing, we have a fatigue rated universal testing machine. In that, member level testing can also happen, and the capacity of the fatigue rated universal testing machine is 3000 kN. In that, we can do all kind of tests, like starting from full stress strain curve of concrete cubes, to reinforcement bars, to railway sleepers, to couplers, mechanical couplers. So all those things we are able to do the test, and then we have a small size shake table which is about 2 meter by 2 meter. In that we can do scale down model testing of structures on the shaking table. These are the tests we are able to do. And we are doing a lot of Government of India funded project for technology promotion as well as education.
Thank you, Bharti. Now let me welcome Professor C.V.R.Murty. Professor Murty, as all of us know, very renowned person in the area of earthquake engineering. And my session with you have been for the last 3 decades. And I know you have dedicated your entire life into disaster risk reduction and earthquake safety in India. And you were actively involved in creating this facility. So I would like to hear from you how far this facility is able to meet national aspirations with regard to disaster risk reduction.
Thank you for the opportunity here today. India's earthquake problem is real, which means that earthquakes will happen. The only difficulty that seems to hold us back to convince the people of India is that the frequency of earthquakes is rather low, which means that people are willing to risk more, and that is where, as technology providers, we come in. We should look at India being a nation whose built environment is resilient, which means that there should not be large economic setbacks when you're looking at technologies which are resulting in collapses. So our intent, first to begin with, is life safety, and second is property. Coming to life safety, housing has been the biggest contributor to loss of lives. In our own country, 1993 Kelari earthquake and 2001 Bhuj earthquake, and later the 2004 tsunami and earthquake have led to about 50,000 losses in the last 3.5 decades or so, and a much larger number being injured. This tells us that we need to do something very fundamental in terms of providing safety. We're looking at the first level, there has to be technical education. Second, we have to have standards. Third, we need to have an improved practice, professional practice. Fourth, at the governance level, implementation should be very strong. Fifth, we need to have a national policy for safety of the people of India, and then also the property. In the backdrop of all these 5 items, what comes out very strongly is that as technology providers, we need to give standards of construction to the organizations which are offering technologies and to the people of India for being safe. When we talk about standards, traditional technologies, conventional technologies which have been used in the recent decades, and the new technologies, these are the 3 that come to our eyes. What is happening today is that traditional constructions are slowly getting replaced by the conventional technologies, and the niceties of traditional construction are getting lost. So our first responsibility is to demonstrate that traditional constructions are good. The second responsibility is to improve the conventional technologies that are being used to do better than what they are doing today. Because we are seeing in the last 3 decades a lot of common technologies like the buildings with open stories collapsing, which means that we are making some fundamental mistakes. These lessons were learned worldwide almost 100 years ago. Something that we need to urgently amend in the practice, and we have done that through our standards. But when it comes to implementation, I think that's where we need to tighten the belt. But on the technology side, to be able to write a standard for new technologies, we need to go through a drill of rigor, technological rigor, and that is what laboratories like the National Earthquake Test Facility here and across the country will be able to contribute in the road ahead.
Sir, another question in this is which is being asked to me most of the time when these technology providers approach me, that why there is so much fuss about full-scale testing. So for layman or for our fraternity, would you like to explain why full-scale testing is so important when we talk about earthquake simulation or earthquake safety?
Sure. See, when you look at cars, when you look at mobile phones, when you look at hand watches, they are made in millions, and their R&D takes about 3 years, and after that they would just continue to produce. In civil engineering, every structure is unique, And this is where the partnership of architect and engineer come together to create one-off structure. For one-off structure which follows traditional rules, there is no problem, we expect good behavior. But if that structure itself has a very different form, then we know that we are in trouble. Right? Anything that is departing from the simple is actually the worry for us. Now, when you look at technology providers coming with new technologies, what is our responsibility? First thing is that because these structures are big, we cannot test them full scale in structures in such large numbers that they are coming up. We do analytical work. That means on the computer we have to do analysis. And this analysis must consider damage, because when earthquakes come, buildings shake back and forth, there will be damage. The second part is that we need to then do testing. Now when you do analytical work, out of 1,000 possibilities, we will pick up 2 possibilities and do test of the 2. If you start with testing, you don't know which test to do out of the 1,000 possibilities, because when you do analytical work, you will find out which are the critical cases and only those you will test here. And that is what test facilities are all about. Now coming to full-scale testing. Why is full-scale testing important? When you do analytical work, some of the rules, as like when 2 members meet, how do they behave, are to be coded into the computer program. For new technologies, we don't know that. So we need to know how they behave in the laboratory first and then put it inside in the computer program. Now you can tell us, why do the whole building? We can just do a beam column junction. Yes, that's fine. Individual joints may behave, but if you have an open ground story structure, where the open story is so weak and flexible, all damage will accrue there. That cannot be captured by just doing sub-assemblage tests. That only tells us whether the joint is good or not. So here is an occasion, when you look at full-scale testing, the most critical part is whether the joints are able to transfer the forces. So when you shake a building at its base during earthquakes, wherever the mass inertia is generated, that inertia has to travel down to the foundation. That's where the joints play a crucial role. If the joints are able to transfer the force, no problem, inertia force. If they are not able to, then we are in trouble. So the first responsibility is to make the joints stronger and stiffer than the members that are meeting. And the second responsibility is look at the system level behavior. So one is joint behavior. Members we have been classically doing, beams, columns, slabs, walls. We are doing individual components, we are doing testing, they are performing well. But when you put them together, are they talking to each other? The sequence in which we put them determines the load path. Is there a good load path or a deviated load path? We need good load paths, and that is what testing and full-scale testing is all about. Now the last question that will come in your mind is, I have a 40-story building, how can I put it full-scale? You don't need to, because here we are checking connections. Member strengths we can do by traditional calculation. Connections is the key. So if you are able to take a 3-story sub-assemblage from a tall building, then you can do the test of that 3-story and show that the connections are in order. Then your traditional tools for design engineering and analysis, all of that will work. Thereby, today we are seeing that any new technology provider should be able to come forward and conduct 1, analytical work, 2, experimental work, and then take it forward as a technology. So for that, the 3 steps are, first you do testing, second you do qualification, that means there is a standard for it and you are meeting that, and finally you will do certification, which means that you will be able to say that we have done testing, we have done analytical work, and hence under different conditions we are able to say confidently that this technology is useful and safe for the people of India to use. Okay. That's the route.
Okay, thank you, sir. Professor Bharti, we know that you have initiated a very ambitious project which is sponsored by Ministry of Steel. And I come to Professor Singh, being an architect and being partner to Ministry of Steel in this project. Would you like to throw some light on what you are doing?
This project, the story all started with, there was a core committee formed in Ministry of Steel to explore how steel as a structural element can be, its use can be increased in the country, because at the moment if you look at the building construction, it's being done conventionally with concrete structures, RCC structures, but the component of structural steel being used in the present construction industry is, as compared to West, is very minimal. It's very less. So the whole purpose of this project was to look into how consumption of steel as a structural element in the building could be increased. So, as part of this discussion, Professor Bharti and I were brought into this whole this committee, and we proposed a project. The whole concept of this project is that how it is for the masses. So, what we thought that let us start with the traditional systems. As Professor Murty said, we in India have such diverse traditional systems in architecture, and especially in seismic zones. When we are talking about seismic zones, you start from the northeast, you will find Ikora is one of the systems. Then we move further, you will find Katkuni as another system. Then in Sikkim you will find Adjt as another system. Then you move further in the Himalayas, you will find Tak, which is very prevalent in Kashmir and in the Hindu Kush region. And then when you come down, you will find in Gujarat the Bunda system. So these systems have been tested for centuries, and they are all time tested. So these systems need to be seen from that perspective, and we started thinking on this. And another thinking came when we talked about the masses, architecture for masses. We also talked about that Anganwadis. Anganwadis are to be constructed all over the country in huge numbers. So, if we target these two schemes, Anganwadi scheme and the Pradhan Mantri Awas Yojana Gramin, we thought Gramin because we wanted to see how the traditional systems work and how structural steel can be slipped into that system. Because in traditional system you see that timber is being used as a structural element. And timber nowadays in India is very costly, either it is not available or it is very, very costly. So people in the rural areas are not able to afford that. And so what they are doing, they are moving towards the concrete system, RCC systems, which are not very earthquake resistant in terms of you will see the ductility. So what we thought that let us explore the traditional knowledge system and how we can slip in that structural steel system into this system without disturbing the traditional essence of the entire structure. So we started exploring that, and then what we saw that what we proposed was that we took Anganwadi as one of the case studies in research. We took Bunga, the Gujarat model, Gujarat system as one of the system. Then we took, then we thought in the Himalayan region, why not we develop a system which is a combination of Adjt, Katkuni and Tak system. So we started thinking on it, and in Anganwadi, because the Anganwadi has a number of I will say typologies in terms of its capacity. So we designed and developed around 10 typologies in Anganwadi, starting from 600 square feet, which was the minimum, and then we the maximum was 3000 square feet. So all the systems, all the typologies, the structural system is based on structural steel. And depending on the region in which it has to be constructed, the local available material could be the filler material. So the structural system is of structural steel, whereas the filler system is the traditional locally available material, whether it is bamboo when we go to northeast, whether it is mud, whether it is stone, or whether it is brick. So depending on the regions, we give them a structural system, and one of the very special features of this structural system is that it is on nut and bolts. Because in rural areas, it happens like that there might not be electricity, fabrication will be difficult, and secondly, when we compare it with the RCC system, in rural areas especially, the RCC system, the quality cannot be ensured. So the quality was one of the major reasons. Whereas, and if you look at the structural steel system, they are manufactured in industries with a set pattern of standards. So the structural system prefabricated in terms of the elements and the structural components of it could be done in the workshop in the industry and could be transferred to the site, and through nut and bolting system it can be erected in a very fast. So I think what the test we did, we were able to erect the structural system within 3 to 4 days. So it's less time consuming also, and the quality is assured in the structural system. So we did the same part when we came to Bunga. Bunga also we gave a structural system in steel, structural steel, and rest of the material, filler material, we advise to use it in terms of the local area. And in Katkuni, in the third test, we had the system of Katkuni, Dhajidiwari and Tak fused together, and we tested it with brick as a filler material.
We have been working, and now we are actively trying to pursue some of the other technology providers that this is the national facility and it has been built to keep in mind the national priorities of earthquake safety and disaster safety, and that is how we are trying to promote the whole thing.
I think your efforts are praiseworthy. Another, just a small question. I think you are doing a very good work, but how do you propose to take it to the masses? The entire effort of yours.
See, when you say masses, there are two branches. One is that people who are actually wants to adopt it. So whatever technology, if you are doing through Government of India funded schemes, it is our mandate to release those systems and technologies, drawings and good for construction detailings to available through our website. And while I am talking to you, this is coming to my mind that why can't we do some pilots in the field with the active engagement of the people who have actually funded this project. So if we are able to persuade them, we are able to invoke the passion in them, we can make some of the model in the field. So one way is that all the design details, fabrication, good for use drawing design details are available on our website. But people may not download it, may not use it. So next is that I'm just thinking about it with the help of BMTPC and other public funded organizations. If the industry people who have supported this project, if they can take one step further and make some of the houses in field, I think the popularity of this scheme will reach to the new height. One way is that. Another way is that the newer technology providers will have to come forward. We will also, from our side, we will also make some effort so that we becomes visible, because it's often said that even if you are doing good job, people are not knowing it. So we'll take help from organizations like yours and some other organizations so that we become more visible. And in any way, we are Government of India funded institution, so our mandate is what the government aspires to do.
Thank you. So now I come to Jaswant, I think one of the youngest designer we have in our country. Jaswant, I know you are adjunct professor here, and right from the beginning establishment of this NETF, you have been supporting Professor Bharti and all of us with regard to design, conducting these tests and all, and whole amount of your hard work you have put into this. I understand from them that we have been testing one of the structures. So today we assembled here to test one of the typology, which is quite prevalent in the country. Would you like to give us the overview of today's test? What was the test? What was the typology? And what kind of results you are getting?
So today's test that the specimen that was tested today is called the Bhutia, which is more popular in the Himalayan belt. It's right across from Sikkim towards the northern side, maybe Uttarakhand and even northern of portions of the country. These are basically built in places where you need to remain warm. So the thicknesses of walls are substantially larger. Normally, if you look at in the rest of the country, you have about 9 inches wall. And now we are going to about 150 mm thick walls. So 230. These walls are usually 300 or more. So in this case, the walls form a large mass of the structure, and we know, most of the people who are listening to this podcast would be aware that the mass is a very big problem in case of seismic loading. If your mass is large, you have more damage if it is not detailed properly. So we had to keep that in mind and design the structure in such a way that in spite of having a larger mass, we were able to capture that mass into a framing of structural steel tubes which hold it together even during the load. And today's test has actually proven that to an extent which has gone beyond what is expected by our national standards. We did a small calculation while the test was going on, and we saw that the level of acceleration that this structure can take is much higher than what is expected out of, or what is expected when the expected earthquake strikes that region. Now, having said that, why steel and not concrete? So that is one of the things that always comes to the picture. Our country traditionally has 3 types of building material: masonry, concrete and steel. These are the most popular. There are others which are also being practiced, but these are the most popular. And even in our school or in engineering curriculum, concrete and steel is being taught very popularly. And most of our engineers understand concrete and steel. Masonry not so much, but it is being practiced. And these structures come under non-engineered structures. There is no standard which can tell you how to design these structures. We are trying to build those standards, but currently in the undergraduate level, design of masonry buildings is not very well understood. So putting together what is being done and trying to see if it will behave in the manner that we want, which is the safety of the residents. It should not collapse, it should not kill people. So keeping that in mind, we developed this system based on the existing system. So if you get an opportunity to see the building that we tested, you can look at it on the website also, where we have timber, we have replaced the timber with steel. So like Professor Singh just mentioned, the replacement of timber with steel gives it an additional advantage because steel inherently is a better ductile system. Not to compare with concrete, concrete can also be made ductile with the proper detailing, but a little more effort is required. Even in steel, we have to make it ductile. There's different ways of making steel ductile and different ways of making concrete ductile. So in this structure that we did today was a wall which was encased in a steel frame. The steel frame was holding the timber masonry together so that when the shaking happens, the way we simulate the load is we push the structure at the top back and forth to simulate the effect of earthquake. So in that case, we developed a lot of cracks, but none of the bricks or the top of the structure came down, which basically means that the performance structure was much more than what we had expected.
Another question just was to you is, I think you're doing a good work, but to a designer, a conventional designer, we always resort to, software and all. And when you want to replace, say, timber by steel or, RCC by steel, so what would be your, how do you guide these designers to replace, the existing traditional system with the steel skeleton and all these things? What kind of software they should use? And how should they go about it?
So, going from what we have done now, we didn't use any sophisticated software till now. We are using the basic software which is elastic analysis of the structure, using that and using the current codes and the standards that are available for design of steel and masonry structure, and to a certain extent concrete also. We are calculating the forces which we expect on the structure, and based on this structure we are designing the connections of the building. Even the base of the building, the foundations of the building are designed based on the current understanding, and that does not need an improved understanding or understanding which is not available to the common design. So that also was one of the part of the beginning of the structure. We will not do a sophisticated design which the normal engineer in the country does not understand. So taking this structure, how are we going to design it? We have documented that whole thing. Every engineer can look at the documentation, the calculation. The process is straightforward. It's what everybody is doing. Even a normal bachelor's graduate degree civil engineer would be able to understand what we have done. And with a little bit of curiosity, he will be able to understand what innovations we have added into the structure to make it more resilient for the that they are expecting.
Another question is, will this effort of yours nudge the designers to replace the traditional things with steel and other things?
So that I think is already happening in the country. Most of the engineers and architects are moving towards steel as a preferred material. The only problem that we have in India is steel. Whenever we come to steel, it becomes slightly expensive, maybe about 5-10% expensive compared to concrete structure. So that is always a consideration. I mean, culturally, as a community or as a country, we have always been sensitive about the cost. So anytime, not only buildings, but any other product also, we first look at what is the cost. Now that cost has to be, we have to change or think a little bit in terms of the long-term cost, the life cycle cost of the structure. It's not just the capital cost, but the cost which is coming as a maintenance of the structure. Whether that cost is considered or not. Maybe our traditional buildings that we are doing, initial cost would be less. But as you go and start using the structure, the maintenance cost may be slightly higher than what you would get for another set of building, another technology of building, which is more durable. So those aspects also we have to consider now and re-evaluate the cost thinking or mentality of our country. That cost of the entire structure of its entire life has to be considered, and based on that decisions.
I think, Sir Professor Murty, I would like to ask you, being in BMTPC, I've been promoting new technologies, and we are also running a scheme called Performance Appraisal Certification Scheme, through which we are also certifying a whole lot of new technologies. I have had discussions with you a number of times. A lot of technology providers come to us and they say that their technology is time tested, proven elsewhere, and they have enough credentials with regard to full scale testing, with regard to whole lot of engineering parameters and all. And then normally the question comes to us that why do we want to do it again and again? And all of us know it's quite time consuming, it requires dedicated efforts. So my question to you, to our fraternity, the technology providers, they have a whole lot of doubt, as if we don't want to, promote these kind of cutting edge technology in the country. And you are also, changing the code CED39 to BIS. So, I mean, can you explain in a simple language how do we validate these new technologies when we are embarking towards developed mission by 2047? We have a couple of other issues. Jaswant was talking about life cycle cost, a whole lot of climate change, thermal comfort, all other things are coming. Of course, I know safety is the top priority, but to our technology providers who are coming to us and asking for these kind of things, that it is validated, it is time tested, proven with the passage of time, it has withstood earthquakes in different parts of the world. So how do we validate these technologies? Do we have any shortcut or any other method which can give us confidence so that we can go to the field with these new set of technologies?
I think the most pointed question that is coming out very regularly these years is, let me begin by saying that in the built environment, we need 5 tenets to be followed. First is safety, functionality, sustainability, in that order, and then aesthetics or economy. Now, between these two, if you pay more money, you get aesthetics ahead. If you pay less money, economy will be ahead. The question here is, so far whatever technologies we are using and whatever happened in the past, which tells us we have been jeopardizing safety. So today, if anybody comes with any technology, our primary worry as a Government of India organization, as a public organization, is the answerability about the safety of the people. And I think that is the key point on which all of us will go a little more cautiously and carefully and be doubly sure that whatever we are recommending is actually good for the people of India. Now, technology providers will borrow technology from international trade fairs and come to India and say we would like to implement this technology. Perfectly in place as far as they are concerned. As far as we are concerned, there are three questions that bother us most. First off, is that the design standards from the countries those technologies come from are different. So the margins that they use are different and margins that we traditionally use in the country are different. Margins of safety. Second question is that they have a very rigorous professional environment, like the licensing of engineers, which we don't have. In over 10,000 municipal bodies that we have in the country, we don't check safety in any of those bodies, with exceptions of some structures where government will say, get it verified by a certain group of people. The third worry for us is that today, as we stand, the new technologies that are coming at such a fast pace that we are looking at answering. First, we said we are worried about education. Second, we are worried about professional environment. Third, we are worried about the fact that the artisans that are working in the other countries, and the artisans who will make our structures are different. They are not necessarily having the same level of skill. So the quality of structures that we will build with these three deficiencies is going to be radically different than the quality of structures that they have been building traditionally in their countries. So while I would be happy and welcome all the technology providers to bring any technology in, it is the responsibility of both the technology provider and the technology certifier to say that it is indeed in keeping with the principles of safety of India. Right? People safety. We are answerable under the Constitution, Article 21, that we must not only be safe, but we must make sure others through our effort are also safe. So it's of utmost importance. So what we are saying here is new technologies should come, but we must go through the drill of approving new technologies. For example, in the medical industry, a new medicine takes 35 years to be approved, right? In the case of automobile industry, a new automobile will take about 5 years to get approved. Looks like it's only in civil engineering we don't even have 5 days for approval. I think we need to give a little more time. A child is born in 9 months. I think a minimum of a year will be necessary for us to go through the drill of analytical work, experimental work, and then provide technology. They may have done tests in other laboratories. What is also important is on the Indian soil, if you do a test, that weighs a lot more because people of India are answerable to India. When tests are done in other countries, they are not necessarily answerable to us, they are answerable to their country. So we need our own people to stand by and say that indeed we are going to be safe with this. If you are looking at India to become self-reliant, India to become a developed nation in the next 25 years or 20 plus years, I think we must take some difficult decisions today. And one of them will be to say that I will keep safety in the driving seat here and after for the entire new built environment that we will create. Whatever India is there, the urban India is going to be 2.3 times larger, which means we have a lot to build. But if you build it safely, they will also last longer. If you build it in a hurry, it will not only hurt life, but also we will lose the property very quickly. Right? So our responsibility is to the people of India, and so we have to be lots more careful when we say that this is good for our use.
And it's just an added question to this. I am also involved in National Building Code, and in National Building Code, I'm writing a part 5, where we are allowing new technologies or new materials to come in with a set of rules or guidelines. Can't we have, because you are also championing CD 39 and equity, can't we have certain transparent guidelines or SOPs which will enable at least these technology providers, cutting edge technology processes to come to India and at least work? Because right now they are lost. Somebody asks them to do full scale testing, somebody asks them to go to BIS, somebody asks them to go to some IITs and all and get it certified. So can't we have a very transparent SOP or procedure or whatever you may call it, which can be given straight away to these technology providers, and so that they can work within a time frame to get their technology ready?
Indeed, the 2025 new NDC that's coming up will have the answer to this very pointed question. What we are saying is that you can come with any technology. We welcome that. But you have a stepwise procedure, you will adopt this. It's going to be transparent. First off, what we are saying is conduct analytical work and convince yourself that your system is good. Second, we are saying conduct limited number of experiments of full scale in nature and show that indeed the claim is valid, that the structure is safe. Third, you will say, is it implementable by everybody? This is where the question comes. So as part of the Earthquake Indian Committee Bureau of Indian Standards, we came up with a testing standard. So the different laboratories testing by different methods and protocols are not going to be acceptable from now on. We'll have a single benchmark testing protocol. So that will give you a confidence that when the same specimen is tested in two different laboratories, you will likely to get similar answers. Today, since that benchmark is not there, they're doing some set of tests and these are doing some other tests. So we are not able to talk, not able to complete the sentence. I think that's the big turnaround here now, that very shortly you will see the Indian standard for earthquake testing of structures, which will put everybody on the same benchmark. And it's a transparent process. We're also asking that the governments and the other private entities which would like to promote any technology to please adopt this procedure, and thereby you will be able to see uniformity across the industry.
So my last question to all of you would be that, I myself worked in CBRI for 35 odd years, and I know that what you do in lab is something under controlled condition, and when you try to project those things in the field, sometimes we fail miserably when we come to implementation. And here we are doing a project which is directly related to the field, and we are doing a full scale testing here, we are simulating the earthquake load. We are doing the construction here, as you said, with artisans which are trained and all. So with what confidence these results, are you ready to take these results to the field and implement them in the field? I would like to ask all of you.
Yeah.
So we'll start with Bharti.
Right. So the kind of test that we have done so far in our laboratory, that includes 7 3-story structural systems. 7 tests which have got 2 structural systems, the moment frame system and structural wall system. And besides that, we have done 5 tests using structural steel. All the tests have been executed with identical systems which are actually implemented there. And all the tests, everything has been documented, recorded and publicly open. So there is no, the question of doubt doesn't come. Only thing is that the person has to do with the same seriousness. If there is a lapse, there is a lapse. But we are pretty confident about results, and it's obvious. If somebody asks me, I want proof whether the sun is there or not, I just hold his hand and take him back. Look, sun is there. Why do you have to prove that sun is there or not there? You just go out, open window, go out and see the sun. It's as clear as that.
As an architect, what would you like to say? Because architects have the final saying. We go in the field and they say, okay, change this. So how will you relate this work with the field?
Actually, if you look at what we have done, and we have tested the systems, the next step, what I see is that the most important point is the acceptability. So what Professor Bharti said, we need to have such projects implemented in the field, and it should be kind of a prototype showpiece to the people of that particular region, where the involvement of those people are also involved, is there. For example, if we give them the structural steel framework and ask them to do the filler system, so a sense of ownership also comes, and acceptability comes with that sense of ownership. So I think we need to have certain pilot projects in all over the country where we can do certain prototypes with the involvement of the community. And if the community once is involved, the success of the project will always be there. Because we will also learn from their involvement. We might need to do certain amendments in our structural system because for their convenience and acceptability. So once we do that, then I think the community will accept these systems, and it will be implemented either by the government agencies or the private agencies as well.
So pilots are to be done before.
Pilot projects need to be floated in such.
Jaswant, can't we, analytical plus experimental,
Yes.
can't we directly take it to the field?
So I'll answer that question, the previous question that we were asking, how to prove to the user that these are safe. We are making a claim now. This lab actually is making a claim that this is safe. I'll answer this question with the example what we experienced. The first test that we did was the vernacular Anganwadi building, which is a small structure, pitched roof. We did the first test and we learned from that test. I mean, the design that we had implemented was not good enough. So when we learned from that test, we implemented those changes and did the second test. So for the Anganwadi building, we actually did 3 tests. For one building, we did a test 3 times, and each time we learned what was the deficiency in the process of design. If that building was constructed using the current knowledge or the knowledge that was there before we did the test, that building would have failed in the earthquake. So that incremental change that was required, which we gained only after doing the test, was implemented in the building. So this effort that this lab is taking is to understand the deficiencies that are there in the current procedures of design. A design office, when they design based on the code, like I said earlier, that we are taking the current knowledge and applying it. So if that is where we had stopped, the Anganwadi building wouldn't have performed as well as what we expected to perform now, because we have learned from the experimental the testing, and if we implemented those improvements in the structure. The same thing we did with the Bhunga building. The Bhunga first test, although it performed as per the expectations, at the end of the test we discussed amongst ourselves, and we saw that a small increment, a small addition to the Bhunga building would improve the performance to a much higher level. That we have implemented, and that we are going to incorporate in the final design, which was not the part of the original design. So as a part of this experiment or the testing setup, design testing and even documentation, we are putting the incremental knowledge learned from the experimental testing that we are getting. So we do this for this today's test also. There are some learnings that have come. We have to sit together. All of us will understand. We'll go back again, understand what were the problems, how the problems can be resolved. If there were no problem, today's building also performed very well. It has gone beyond what the expectation was. But in spite of it going beyond the expectation, there could be small changes that we can make, which will make it much better. And it's not something that will cost us too much effort. It has to be just incorporated in the original design. It will improve its design significantly.
So having heard all of them, would you like to add something?
Yeah, on the matter of variability in the lab versus in the field practice, the approach that we have taken is that when a technology provider is wanting to get the technology tested here, we'll say, please come and do it yourself the way you would like to do in practice. So that is one group. The second group is where we are talking about mass housing, mass construction to be done by individuals at a retail level by individuals. We are calling a mason who is generally practicing around here to come and do the masonry work. So there will be imperfections in that, and we are leaving it that way. For example, today's test also we saw that we could have done better, but we can't say to the mason necessarily, because we do expect certain amount of errors and omissions in a common man built, self-built houses structures. So that part is incorporated. The experiment to experiment, the incremental improvement we have gained over the years, and the eyes with which we saw 17 earthquakes in this country in the last 35 years tells us that these structures, after the tests that we have seen, will definitely perform better than what we have seen collapsing in those earthquakes, right? Masonry structures, brick stone over stone structures, or even uncared for reinforced concrete constructions. All of us, the way we have documented, if these drawings get implemented, and I like the idea of the demonstration structures. If you're able to show that to the people and tell them how to build it, handhold them for some years, 1, 2, 3 years, so that a large group of people will learn it and it will internalize in the generation. And the next generation will learn from that generation. I think we should be able to, with no hesitation, suggest to the people of India that we have better structures in proposal than what we are building already.
So thank you very much. I think I would love to have
शैलेश जी,
more discussion.
एक मैं
please.
थोड़ा टेक्निकल डिस्कशन हुआ तो मैं थोड़ा अपनी मातृभाषा में इसको कहना चाहता हूँ कि भाई हमने जो टेस्ट किए हैं उसकी एफिकेसी का क्या सबूत है। तो थोड़ा टेक्निकल से हटके मैं कहना चाहता हूँ कि भाई सूर्य के होने का क्या सबूत, अगर भरी दोपहरी में कोई पूछे तो लिटरेचर पढ़ाने की जरूरत नहीं है, दरवाजा खोलिए, हाथ पकड़ के बाहर ले जाइए, कहिए आंखें खोलो, ये सबूत है।
Very nice. Correct.
Thank you very much.
So I think with just because of paucity of time, we cannot continue. I would love to have this again and again. So next time, again, we will have this session.
Yeah, sure.
So thank you very much, all of you, for
Thanks.
this session. I'm pretty sure these kind of studies and projects will definitely take India towards resilience. Thank you.